to my second segment of the live streaming. This again, I am a singer, eternal voice at your service. Going back to business and academic information business. Okay, now I momentum transfer summary. Then it's about time to go to another transport phenomenon, which is called the heat transfer. So heat transfer is very exciting, guys. I really love this in college. And shall I say this is one of my favorite topics in unit operations. Okay, talking about heat transfer. I love because I can relate, meaning it's very easy to understand. For example, mass transfer. Mass transfer also could be, but more on the heat transfer really. Okay? And this heat transfers also apply in the designing of an evaporator heat exchangers also. From the word itself, it's very, obvious. Heat exchangers and also heat combustion engines. Okay, so this is very applicable, right? Okay, so I love this topic. Oh my gosh. It doesn't mean that I love this topic, I excel the most, but I just love it. As simply as that. Okay, as simple as that, okay? So heat transfer, oh my gosh. Really? So we go now to the definitions. Okay, first, before going further, let's do the concept. Or, what's really the concepts for this. So heat transfer. And then I will be able to illustrate also. Okay? Transport phenomenon, heat transfer. Okay? Uy, hurot na siya akong pental pen, guys. Oh my gosh. What's gonna... Hindi ko blind source sa pental pen. It was very, very obvious. It's already conscious. Oh my gosh. Black pental pen. Oh my gosh. Heat transfer. So start with flux also as usual. So heat transfer. Uy! Still consumed. Kaloka. Really? Really. Heat transfer. Oh my gosh. Oh, okay. This is good. More good, right? Okay. Flux. So this is actually heat represented as capital Q. If you can remember in physical chemistry and in thermodynamics, there's a lot of heat energy study there. Okay, so that basic concepts also will be applied here, specifically in the heat transfer through the transport phenomena. Okay, so this is dq over dA. Okay, dq over dA is equal to the thermal conductivity. Okay, thermal conductivity. Okay, like what you should agi do in fairness. O sige tagyaw yun ang ganda pa dili mo agi, right? So what can we do now? Okay. Oh my gosh. So K, chararat. Okay. Delta T. Okay. Delta T over dL. So this is the flux. Again, what is a flux? A flux is defined as the rate of transfer per unit surface area or per unit cross-sectional area. It depends on the geometrical shape of what you are considering, okay? Like that. So this is dQdE is equals to thermal conductivity times d capital T over dL. So meaning derivative of T over derivative of the length or the thickness, or delta change, the small triangle, T, dL, okay? If we have a calculus for this, we can have, just obtain the limits. Then if you use the algebraic expression to solve this one, then it would be a little bit easier, right? So this is the flux. And now we go to the rate of heat transfer because it's specifically the heat, right? So we are having now, again, algebra, but I don't want to emphasize already, okay, because I discussed already in the part 1 of my discussion, right? If you are following through my live streaming, and you can really observe the proper flow of my discussion. Okay, guys? Since, just understand quickly, okay, like that. Oh my god. Okay. Shout out pala to Ma'am Maria Sippers Respondo. She is an accountant. And then there is an assignment, a math assignment from her daughter. And he chatted me in the FB Messenger something because he's a little bit confused. But she's a little bit confused. What is the answer? And then the math is all about, algebraic expression only. I told her, Fritz, this is only algebraic expression. I told him, this is not requiring the formula. Okay? Like that. Ratio lang talaga siya. I told her, 7 over 9 for x over y and x plus y is equal to 100. So we have to do a correlation of two quantities only. Okay? And then we got the answers correctly. Okay? Okay, so ratio proportion is very important also, okay? And letting x and y unknowns in algebraic expression. Okay, you don't have to memorize that one because there's no specific formula for that. Okay, all you have to do is to understand. You get the point? Okay? If you talk about ratio, proportion like this, there's no such specific formula for that. Okay? Now, going back, share lang ako. Okay? dQ over dA. So we now go to the rate of heat transfer. So, rate. Okay, so there's time involved. Okay? My gosh. So this is gonna be dQ over dt. T stands for the time. So what's really confusing sometimes is the declaration of the variable, right? Sometimes capital T is for the temperature. And sometimes also the T is also for the time. Then that's why I keep on telling you guys that rate have a time in the denominator, because somewhere along in my discussion, I represented a letter in which it confused to the other T in the temperature, right? To make it safe, I'll mention specifically. You get the point? Actually, we can use also dQ over dt, the small letter t corresponds to time, but I'm convenient in using capital T. So that let's agree that if we talk about the rate, there's a time in the denominator. When you speak about fraction, there's a numerator and a denominator. So the denominator is in the lower part of your fraction, and the numerator is in the upper part of your fraction. So denominator, meaning the time is in the denominator. So it's gonna be dQ over dt, okay, or let's say joules over second. Calorie over second, erg over second, watts over second, horsepower over second, British thermal unit or the BTU over second. There's a lot of unit of energies if you try to compare that one, not limiting only to heat energy. Okay? But all of them are the unit of energies. You get a point? It has the same unit. It has the same energy, general term. Not the units, sorry. Okay, so dQ over dt is equal to, since you cross multiplication clause, then you can obtain automatically the thermal conductivity. Okay, my gosh, nawala. Thermal conductivity. Basta ganito akong i-discuss ninyo, if a substance has a higher value of thermal conductivity, that could prove technically that the substances are highly conductive to electricity. So these are usually metals and elements, something like that. Now, if your substances has a value of thermal conductivity, that could mean there is a higher resistance. If there is a higher resistance, there's a greater fraction, so it will oppose the conduction period. Conduction period of certain substances, then it is an insulator. Okay? Insulator has a very, very high value of resistance, but lower value of thermal conductivity. You get a point? So how can I say that the relationship is Sotero? I can say that because we have a formula for that. Okay, we have thermal resistance. So thermal resistance is equals to the length, okay, the length over the thermal conductivity. So the thermal conductivity and the thermal resistance or the resistance are inversely proportional with each other. That could mean if we have a high value of thermal conductivity of certain substances, then of course your substances will have a lower resistance than that. Those are insulators, non-conductive or less conductive to electricity. Example, concrete, wood, plastic, rubber, mud. Okay, so to avoid electrocution, then you have to step that in the ground so that there will be no higher conduction of the electricity. So there's no direct path towards your body. Okay, because it is the path that can electrocute you, because the electrons will flow there. Okay, and then going to the inside parts of your body. And since we have also electrical conductivity, since we are having oxygen atoms in dili-dili alatul, okay, we drink water, and water has a high polarity, negative charge. Then we have an existing amount of electrical energy also, though it is at high, but I'm talking to you, at least we have an electricity in our body, then bingo, it can create electrocution by the reaction of the higher polarity oxygen to the electrical energy that is in the presence of the electrical cable or the path going to your body, something like that. Okay, so that's very clear. You got the point? Okay, then if you wear also a hand gloves, the hand gloves also can serve as an insulator. Okay, at least. Okay, that's the point there. Okay, so thermal resistance, or the rest, I put thermal because it is heat transfer. It is governed by the change in temperature. Okay, so I put thermal. Actually, this is only resistance, just like in the Ohm's law. Okay, practical electricity, Ohm's law. Voltage is equal to current times the resistance. The resistance there is simply the resistance, but in this heat transfer, our resistance is thermal resistance. Okay, specifically. You get a point because we are dealing here with heat. HEAT, governed with the changes of temperature, or the temperature gradient from higher temperature to lower temperature, something like that. Okay, you got a point now? Okay. Now going back, so don't forget that formula, a very, very, very easy to memorize formula. And then if you are a student right now, an engineering student in front of you, listening to my virtual discussion of this, live streaming, then you can memorize. And starting memorizing every minute, every second, and put that in your brain cells. And then pardon in your second year, third year, fourth year, fifth year, it will be retained in the cerebral part of your brain cells, and then you will never forget that, something like that. Okay, just like density, like that, formula of density, formula of molar mass. Okay, so as far as I could remember, I memorized that in elementary level. Okay, the density. Okay, something, and the conversion factors, mga centimeter, mga feet, mga anak, di-memorize na ako siya when I was in elementary. Okay, then when I go to high school, we accumulate. When I go to college, you accumulate again, and it will develop, improve, and then added for some, and then it will maximize. Okay, it will be maximized, and then when future examinations come, it will be a great advantage. Just like a pool, P-O-O-L. Our brain is just like a pool, and there's a very wide water surface in the pool. So if there are a lot of knowledge stacked there, by the time it is needed, then it will be used. Something like that, okay? Get the point? So advantage if you have really a rigid, stacked knowledge and acquired knowledge. Since elementary education talaga siya magsimula agad. Okay? Practice memorization and understand what you memorize, and bingo. Okay? Of future unexpected examinations, ganun talaga siya parati. Especially this math and science. These are partners in crime. If there's a science examination, there's always a mathematics. Okay, they are partners with each other. Okay, and then a little bit of English, of course. English is always be there because all questions are interpreted in English. Okay, especially if you're applying for a job that is a multinational company, an international company, they are using the standard statements in English communication or English language, not in your specific local dialect, right? Especially you're applying for a company that is, for example, Saudi Aramco, something like that. Okay, Nestle Philippines, like that. There's a branch in different places all over the world. Okay, Alaska Powder Milk. Okay, Pepsi. This also has another company branch in another country, something like Coca-Cola. So those are international companies, and their examination, when they accept, employees, they will have an examination, and usually it's gonna be like mathematics, science, psychological test, abstract reasoning. Abstract reasoning, all about sequences and pattern of certain symbols, and you have to identify what's next, and then shot. And then also there is a little bit of multiple choice, and all will be interpreted in English, really. So it will be an added advantage if you are having a good vocabularies. Okay, you get the point? The synonyms, the antonyms, the homonyms, so that it can be used also in the examination, what is known as the logical relationship after you read a story, right? For example, company A, company B, so arrange in logical order from A to E. If you understand the story, then you can easily, pattern what comes first, second, third, fourth, and final. That if you have a great comprehension, then you don't have to read it again and again and again, because it will accumulate in your brain cells. It's going to be like number 1, number 2, number 3, number 4, like this. So it is logical relationship examination in English. Sequencing, what's come first, second, third, fourth, fifth, right? That is also one type of examination in English, aside from the vocabularies and the grammar, right? If you can remember. Okay, so some employers have their entrance examination in selecting prospective candidates for a particular position in the organization. Okay, and that's the rule for the HR of the company, to troubleshoot who are really competent enough to do the job in the future. That's why they assess the qualifications, something like that, including the certificates, like that, the experiences, the skills, the knowledge, and everything. Okay, going back to the dq dt rate. Okay, dq dt is equal to, since we are already cross multiplying that one, so we can obtain now the surface area beside the dtdl. Okay, I don't have to illustrate how to get it because it's very easy, right? Cross multiplication only in algebra. Okay, so we have thermal conductivity. Okay, do I talk very fast? Okay, that's my weakness. I talk very fast, really. Somebody told me, just talk slowly. Really, honestly, somebody already observed that. Okay, so T times A dTdL. It's gonna be like this, the formula of this one, right? Okay. So dq over dt is equal to the thermal conductivity multiplied to the delta change in temperature over the delta change in the length. Okay, the length. It depends on the situation, on the geometrical shape you considered. Would it be a rectangle, sphere, trapezoid, rhombus, cylindrical in shape, cube, okay, cubical shape, something like that. Because it matters the area there. Okay, so and the volume in the area. So you should also memorize mga area and volume specifically. So in different shapes. So guys, memorize na talaga. Starting memorize, get all the shapes. Tanang shapes isago, and then memorize the area and the volume. Okay, ang area ng volume magbalik-balik lang yun siya sa examination class. I told you. Okay? You get the point? So ay mag-limit sa square o sa rectangle lang siya o sa sphere. Kung yung mga common ng mga ana. So add itong mga uban, itong mga trapezoid, rhombus, mga gano'n, di ba? Ellipse. Okay? Hyperbola. Ganun na ba hyperbola? Di ba? Merong ganong hyperbola in, ano ba yun? In differential calculus yung hyperbola. Yung parang curve ba? Gumanon siya, curve facing upward, curve facing downward. Di ba mga hyperbola, ganon? Okay? A graph, a type of graph. Right? So, isagusa din yung mga kuan niya, mga area, mga volume, ganun, chupa-chucho, ha? Okay? Ayun, ilimit sa mga simple lang na mga kuan, mga square, rectangle, na gano'n. Okay? So, maximize. So, that is the study of geometry. I think that's under analytical geometry. Right? We have analytical geometry, right? And then trigonometry. You know, trigonometry, dealing with angles, radians, too much pi like this. Okay, you remember that one? Okay, so you can connect that there, the geometry, and then combine with algebra. But the most popular really is algebra. Really, okay? Something like that. And then we go to the driving force now. What is the driving force of this heat transfer? The driving force, guys, are the change in temperature, the difference in temperature, and the temperature gradient. Okay? So this is temperature gradient or difference, something like that. Okay, when you talk about gradient and difference and change, guys, it's always T2 minus T1. Okay, but you have also to understand, guys, but there is more appropriate to that. Okay, T2 is the final temperature, T1 is the initial temperature. Okay, because T1 is just a designation by a number. Okay, that's hypothetical. Okay, but if you speak about initial temperature, it's very clear in your brain cells, oh, this is going to be the first temperature or the original temperature. And if you speak about final temperature, oh, this is my last temperature going outside. So that is highly specific compared to using T1 and T2. You get the point? Okay, it's better to use T2, T final minus T initial. Okay, in my part, it depends on your convenience, but for me, I would rather use, it's easy to understand, use final temperature minus initial temperature rather than T2 minus T1. You got the point? Okay, sometimes T outlet, T inlet. So it's very easy to understand also, right? T outlet, T inlet. T outlet minus T inlet, okay? You got the point? Or T in the product minus T in the feed, something like that. So we can also say T in the exit minus T in the entrance. There's a lot, right? It depends on the problems, how it was being phrased, the sentence or the paragraph. Okay, then you can understand really. Okay, something like that. So we go to the unit. What's the unit of this heat transfer Sotero? Okay, heat transfer is gonna be expressed, guys, in the physical chemistry and thermodynamics. BTU is the popular unit for this. BTU, British Thermal Unit. Okay, but in unit operations, it's gonna be joules and calorie somewhere along the way. So let's interpret na. So dQ over dt. Interpret. So dQ, ganon. Q is heat. dt, T is second. Okay, so second. Q is, mapili na ka, calorie, joules, BTU, erg, okay, watts, horsepower. Right? So mapili ka according to the context on the discussion. Since we are discussing here heat, so it's gonna be, the more closer is that the joules or BTU or the calories, so it's sometimes only in the watts. Okay, because it is more on the, on the motor pump, on the equipment. So that is more on electrical energy context. But in here, it's more on the heat energy context. So we need also to troubleshoot the applicability, okay, before we solve. Anyhow, we can convert that one to save time ng good siya, that this is referring to heat energy, not electrical power energy. Okay, there's also power energy because power is equals to work over time. You remember that one? Like that. And power is equals to the electric charge times the voltage. Okay, remember that one? We have also current is equal to the electric charge over the time. So there's a part you can separate that one. Because it will be also used to follow up the question also. We'll say, how much time, that is blah, 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 blah. So you can, that's the time you will use the power is equals to work over time. Especially for the, 1 horsepower is equals to 746 watts. Ganun, may baka lagi na mo kay, guys, okay, this is a technique. The thermal conductivity, guys, is in watts. Okay? Watts per meter degree Celsius. What comes in your brain cells, it can easily connect to the electrical power energy unit, which in terms of watts. So it's easy to multiply that one, right? You get the point? So it will be tempting to do that. Okay, 746 watts is equal to 1 horsepower, and you have the thermal conductivity is in watts. Di ba tayo ba kasi multiply? Something like that. And then you can play around the units, and you can cancel the watts, and you can keep it for the time. But that is only a trick, T-R-I-C-K, trick. Because you can also convert watts in terms of joules. Again, basic physics. Okay, 1 watt is equals to 1 joule per second. So we can convert the watt to joules anymore. Because joules is the preferred heat energy unit na talaga siya. Okay? Then if you talk about biochemistry also, biological substances already, so you are now talking of calories also. That's why when we do the exercise, how many calories we burn, that's heat energy also. Okay? During our metabolism. Okay, when we release our sweat during jogging, exercising, cycling, running, and do a lot of physical activities in the gym. So that's also heat energy released in terms of calories na siya. Okay? And it's also possible to convert that watts back. But the context is not appropriate because that is not electrical energy. But we can convert. There's no question about that. Okay? But the applicability, the suitability of the statement ba. Okay, you got the point? Where it applies. Matters a lot also. Okay? You got the point? Muna siya nahitabo. So dq over dt is equal to, this is gonna be joules per second na talaga siya. Okay. Guys, my technique also when I was in college, if I forgot the formula, I still have the unit in my brain cells. Then I can adjust the formula to that. For example, if I forgot the unit of the electric charge, for example, the unit of an electric charge is coulomb per second. So, it's gonna be electric charge over time. Then bingo, that is my current. Sometimes I forgot that. But through the unit, I can troubleshoot the formula. Okay, there's an alternative. Do not depend on one alternative only. You should also find another alternative because our memory failed sometimes. Okay, especially when we are running out of time and then we memorize a lot, and sometimes you are just only memorizing without understanding it. Okay, it could not be denied, things like that when we are in college, in high school, there's a lot of subjects, right? Okay, then the chance is we memorize and we cannot understand well. Okay, so to avoid that, have another option. Take the units and you can adjust what is the formula for that. Example, density, di ba? Kilogram per cubic meter, grams per meter. Kibaw maka ang mass is in the numerator and the volume is in the numerator. So you can create your formula if you forgot the density is equal to mass over volume by trying to have the general quantity. Ganan. So kilogram, mass. Cubic meter, volume. That's mass over like this. Okay, ganan. Okay? So it's very easy, right? 2 alternatives good siya, guys, ha? Okay, so that you can easily answer math question, especially question that is very easy to answer. Okay. Because sometimes also our mentality, even though that is very easy to answer, we have the mentality to take that as difficult. Me, including me before, I take that as a difficult, but it is really not difficult.
The Bluetooth device is ready to pair.
You get the point? Really, guys. And then when I scan the page of the book. Oh my God, yun na ako na daily. Okay, so gilisod-lisod yun ako akong self. Wow. Diba? So some students are like that also. Or few students are like that also. Okay? So we should be positive always to think that that is not difficult to solve. So that we have the mentality that we can really solve that. Okay? By positivism alone, we can answer right. So it's gonna be like that. Positive attitude. Okay, so joules over second. Ay pag una lisod man nimo, feel it lisod. Di ba? Dili na kalikayan. Okay? Ingon ito ka tanaw na to sa paragraph mag daghan makay siya uy. Dili ta lisod lagi kayo siya. Pero actually dili siya lisod. Imo lang siya nang itoki ra jud nimo siya tagsa-tagsa. Okay? Ganun siya. Okay, component by component and ganun. Okay? So muna siya lessons learned. Okay na ako when I was in college. Okay, na maglibog dayon ko kung daghan na jud kaayo. Pero actually it's not. Okay? So, joules over per second. Muna ni siya namong dq dt or your rate of heat transfer. Ganon. Ano? Muna na unit no? So, joules per second. Okay, guys? Joules per second. Rao? Tanawan ninyo ang unit guys ang amo. Aggregate and object if I have a wrong unit. So that I can put in my description. I beg your apology due to my continuous and spontaneous discussion. I missed out some units like that, and I have to justify in my description of the title of my video. It's gonna be like that, okay? So now we go to the scientific law and scientific theory. So this is applicable in the Fourier's law of conduction. This is Mr. Fourier, a scientist, discover heat transfer through conduction. Okay, now I'll show you. If we have the conduction, we have also the convection. Okay, like this. Dili ni siya convection na katong C-O-N-V-I-C-T-I-O-N ha. Nanam say convection, your belief. For example, I will believe in my own convection that I can do these things possible. Convection, C-O-N-V-I-C-T-I-O-N is another term, meaning to say your belief, okay? And then, or your perspective. This convection is C-O-N-V-E-C-T-I-O-N, meaning like, not convect. Okay? Convection, not convict. Gahin ito sa. Okay? This is convection. Not convection, okay? Because the same shall rhyme, R-H-Y-M-E. So use the convection, the eagle. So C-O-N-V-E-C-T-I-O-N, not the I. Okay? You get the point? Okay, duha ra ba ka convection, guys? In English. Okay? This is not a homonym because this is not having the same spelling, but rhyme, R-H-Y-M-E, the sound. It produces somewhat similar. So that is rhyme. Usually at the end, when you enunciate the term and the words, so it sounded the same. Something like that. Okay, that's a rhyme, R-H-Y-M-E. Okay, but not homonym. Homonym, the same spelling. Okay, and then different meaning. Something like that. But this is not the same spelling, right? Okay. Now, going back to the unit. Scientific is Fourier's law of conduction. So I have to I do this in an acronym so that we can easily memorize. I remember when I took the Bush International General Certificate Examination, okay, catered by the UK, OSH, London, something like that. I took that in the Abu Dhabi. United Arab Emirates. When I took the examination, it was a very strict examination. It was sealed. All the questionnaires are being sealed before it will be distributed to the examinees. Okay? And then the seat is very far from each other. More than far than I took the Chemical Engineers Board examination. Really. The distance of the seat is very far. And then the proctor will video from the start. It will be open. The sealed test papers in an envelope, and then very detailed. So there's no cheating really in that particular examination. Okay? So sometimes also other courses have, but I think nowadays it's very difficult to do that because the head of the proctor is very strict. Okay? In our time before, the head of the proctor is going forward, going backward, and then his head is rotating all the time. And then even though you will look at the side, your heart beat very, very fast. Something like that. So there's no chance of cheating, okay, or leakages. I don't know with other engineering board examination. I'm just relating the chemical engineering board examination because very strict the proctor, and then he rotate like this. He goes to the front, going to the backward, going to the side. How can we achieve that kind of situation? Okay, that if your hands will like this, you will shake your body. You will tremble, something like that, because the eyes are always watching every gestures you have. Really. I remember that before. Oh my gosh, what's this? Okay, and one sit apart also, like that. Okay, then in the mid-bush, International General Certificate Examination in Safety, the seat is very far. Really, I think it's almost 1 meter. Here, and then the other one is here, like that. Okay, and then how can we? Okay, so the purpose there is you have to make it your own, and you cannot ask your seatmate. But I don't know how the other also, but that's only my time because it depends on the other situation also, not the same. But in our time, really, I thought I will be failing that one because I did not study the last part. Okay, the last part in the international workplace hazards and controls examination, and that is the most difficult because it leads you to think. Okay, what are the control measures, the corrective actions you will be able to establish, and then when you obtain the potential hazards on that particular scenario, so you have to think critically or critical thinking, something like that. I did not study that on the last part of the book, and then oh my gosh, I will be failing this one, and then I use my own, I use my own understanding to answer it. Really. Okay, and then when the result comes, oh my gosh, I passed. Okay, like this. And to be honest with you, almost I will be in the, nasa po yung habogero. Okay, so almost na siya dito sa distinction. Wow! Magbuwang na lang siya 6 points, something like that. Because the scoring of the mid-bush IGC examination is distinction, gananan, na natural pass. And ako dito sa tunga-tungan mo, labaw siya gamay. So, hapit na siya mo sa taas. Charot! Nagibitag ko sa last exam na International Workplace Hazards and Control because I did not study a lot there. Okay? But then for the management, for occupational safety, I have a very, very big score. Because management is easy to understand, right? Okay, and then, and for the costing, there's a costing there. Costing, you need to troubleshoot what's the cost. For example, if you buy these control measures, what is your estimated cost for that, so that it will not have an impact to the environment, to the people, something like that, the sustainability of your equipment regarding the total safety features of your equipment, both if you will be hired as a safety engineer, if you're hired as a safety advisor, like that, or let's say you'll be hired a safety manager. So you have to do that. The impact, something like that. And then it's manageable also because I study it also, but in the international communication. So I did not expect to pass for that really. So July 12, July 12, 2012, when I passed the NIBUSH National Examination Board of Occupational Safety and Health, okay, established by United Kingdom. Something like that. Okay, so diba, I'm telling you, what I did also is that I read and then I understand what I memorized. See, I did not study all in the last part of the book, right? Then why I passed? Because I used my own critical thinking at the time, my own understanding on the question, meaning not bookish, okay? I have my own interpretation, okay? Because again, the paragraph and sentence are written in English. Okay, it's very easy for me to not an arrogant, it's really true, it's easy for me to put sentence. Okay, 1, 2, 3, 4, because there's an essay, something about you will do like this, make a program like this, and then that's my 40, right? Writing, thing. Okay. makuha jud siya nako. Even though wala ko makasagot sa mga technical, but then I can answer by my own self through interpretation of the question. Okay, something like that. It's very helpful also. How you interpret, how you comprehend the question. Okay? So that's the critical part in taking an examination. How you interpret and how you comprehend the question, the statements and the paragraphs in that particular question. Bihagid siya mo matter, really. Okay? Get the point? Ganun siya. Okay. Now go back to the heat transfer. It is the 4 years, capital F. I'll just relate that because I do a lot of acronyms when I took the Bush acronym. And then, for example, enumeration, and then outline, define, explain. The examination of Bush is like that. It's not multiple choice. Okay, like that. Enumerate, list, outline, explain, is a question. Ganon. So, parang gusto ko siya. Okay? Ganon. So, you should be careful also with the type of questions, right? And you should be ready also. So, I put acronym. For example, if the enumeration will be about fire prevention system, so I'll just take note the first letter. Right? So, L. So, I'll put L. Number 2, the first letter is N. So, LNOPT, STP. That's my identification so that I can answer very well. Right? And I can understand each letter and then there's a sentence there. So, by just first letter alone, I can understand what's the sentence in that. My purpose only is to have that acronym so that it will not be rumbled during the actual examination because there's a lot. Okay, so there's a lot of questions, so maybe it will be rumbled and mixed up. That's why I need to put an acronym for that. For example, like this, NLV. This is Newton's law of viscosity. FLC, so 4 years law of conduction. Ganun. So, gamit kayo siya ang acronym in memorization right after you understand it. Okay? You get the point? So, this is 4 years law of conduction. FLC. Okay? So, pwede na kami yun, hala, ang theory ba dito sa heat transfer FLC? Ganon. So, that's 4 years law of conduction. Ngayon ka, hala, NLV ba dito sa kuan yung scientific theory? O NLV, Newton's law of viscosity. Ganon. So, i-practice na yung mga hana. Kadali education, guys. Really. Okay? Just like mga laser. Laser operations in hospitals. Okay? Operations sa mga cataract or any tumor in the liver. Di ba laser operation? Hindi na siya surgical. Okay? Surgical but more na sa laser. So, light, amplification, simulation, emission, radiation. So, that is laser. Okay? So, you should be, you should be clever in that acronym, ha? Para dali na siya masabtan. Okay? So, meaning, light ray is being involved there. So, photon particle going inside the body of a person. Photon, P-H-O-T-O-N. Okay? So, this is a particle, a light particle. Okay? Discovered by Heinrich. Okay? Like that. Okay? Heinrich, Friedrich, something like that. Okay? And Max Planck of quantum mechanics. Ganon. Friedrich, Heinrich daw. Heinrich, H-E-N-R-I-C-H. Muna natay Hertz ngayon, tungod maniya. Okay? Hertz, H-E-R-T-Z, which is defined as oscillation per second, cycle per second, or vibration per second. It depends on the context you are dealing with. Okay? You get the point? Something like that. FLC. Now, conduction na. Matapos na sa conduction. Magulo ka sa convection. So tinatagay ko ni definition nga sa yung nasabton. Okay. Heat transfer of conduction, it is really a transfer of the heat energy through solid substance or solid medium. So, straight ni mo muna, there's no liquid and fluid in here. But there's a movement of atoms and molecules within the solid substance, within the solid medium, mafe, liquid, and fluid. Get the point? So, in convection, fluid will matters. It is a heat transfer from the solid or either stationary fluid, liquid, or gas to a moving fluid, liquid, and gas. There's a combination now of matter in ATTER. Sa ganitong matter, matter is anything that occupies space and has mass. So these are solid, liquid, and gas. In heat transfer through convection, 3 phases of matter are involved. Whereas heat transfer to conduction, only solid is involved. So there's a clear difference between heat transfer through convection and heat transfer through conduction. And you have to understand that. Okay, the heat transfer through convection, it involves now, again, sikat din siya, Newton's law of cooling. Okay, because we have also Newton's law of viscosity in the momentum transfer. Niabot ra gyapon si Newton diri sa second law sa heat transfer sa convection. Really, Newton's law of cooling na siya ang tawag. Apart from that, nasa siya dito sa 3 laws of Isaac Newton sa physics. Okay, 3 laws of motion that he discovered. So he is very brilliant, right? His theory is extended to other topics. Okay, it is still used in higher sciences, something like that. You got the point? Grabe na. Newton's law of viscosity, Newton's law of cooling, 3 laws of motion, and he is also related to the Newton's gravitational force in the planetary science. You remember that one? Gravitational force is equals to the capital G, ganon. Capital G times mass 1 times mass 2 over r squared. Okay, the mass 1 is the mass of the sun, and the mass 2 is the mass of the earth or any planets being considered over the radius in the orbital directed towards the sun. And the G is equals to 6.7 times 10 to the negative 11. Chararat. Nakakaloka. So, mo na siya natabo, okay? So, column, okay? Meter squared, kilogram squared. Okay? So, that's the unit of gravitational force constant. Si Newton gihapon. Okay, that's Newton gravitational constant. Imagine. Grabe nun. Abot siya sa planetary science. Okay? And naabot po siya sa fluid flow. Naabot po siya sa heat transfer. Oh my goodness. He's very brilliant, right? And that's why Isaac Newton and Albert Einstein is friendship. Albert Einstein, who discovered the theory of relativity of time and space in the universe, right? After Big Bang theory in 18.3 billion years ago, the heavenly bodies are, striking with each other, an explosion, and that's the time the comets appeared, the stars appeared, the galaxy appeared, the Milky Way, the planets. So that's the start of the universe after Big Bang theory. Okay, 18.3 billion years ago. Okay, and after that, Albert Einstein discovered that one. That's theory of relativity. Okay, that's what I told you before over and over again. E is equals to mc squared. Okay, theory of relativity. So there's a connection also that to Newton in that relationship. Okay, and then we can use also the the centripetal force there because it's an ellipse. Right? It's an ellipse, so we can use also centripetal force is equals to mass times velocity squared over r. Then you can equate also the gravitational force to the centripetal force, and bingo, you can produce another formula in the universe. Okay? Ganon. Okay, and you apply also if related to here. But Newton is always here. That's why I relate that one here. Okay? Something like that. Isaac Newton. That's why Isaac Newton is the father of modern chemistry. Okay? Blanc is the father of modern chemistry. Your answer will be Isaac Newton. Okay, not Albert Einstein, Isaac Newton. So who is the father of modern chemistry? It's Antoine Lavoisier. Okay, what is the father of chemical engineering? Mr. George Davis. Okay, what is the father of biochemistry? Mr. Alex Newberg. So, maraming siya mga father-father. Okay? Like that. So, you should also familiarize the scientists that is the father of that subject. Okay? Chemistry, physics, ganun. So that nakagamay nga theory of that, of the contribution of the scientists. Okay? Kailangan dyan siya para masabdan pag-ayo ba? Okay? Muna siya nitabo. Okay, now we go to the heat transfer through convection. 51 minsan. 51 minutes. We're already 51 minutes, guys. Nakakaloka. Okay. Taas kayo akong explanation. Wow. Okay, convection. So, did you... Chararap. So, flux gihapon siya. Mag-start gihapon sa flux ha. Okay. So, sa'yo doon kayo kayo kung ang problem yung na, what is the momentum flux? Ganun-ganun. O, ganun na yun. Di ba? So, gamitin din ninyo mga form of akong gi-present. Okay. Now, we have heat transfer to convection na taso. Flux. This is conduction ha. Okay. Conduction. The insulation, guys, you know, of the buildings to avoid extreme heat, to avoid overheating of the equipment, AC, like that. It's under conduction, because that's solid. Okay, insulation. Okay, so that's solid. Under solid, the thickness of the wall, and you put on the pipe, the outer layer of the pipe, you put an insulation. That theory is under heat transfer through conduction. You can use this formula here. Okay. Right? If you see the piping in the building, first floor, second floor, third and fourth, there's an insulation of certain pipeline. Okay, that insulation follows the theory of heat transfer through conduction. And then, thermal conductivity plays an important role for that. Thermal conductivity, okay? Like that. Of course, the length of the pipe, the area, ganun. Okay. Now we go to the convection. Heat transfer to convection. Okay. Chararat. Convection. Sa ganitong convection, that is a heat transfer from one surface to a moving fluid. When we mean of a surface, guys, this is the solid and a stationary fluid. To avoid too much memorizing ba, we will it that also as a general term na lang din siya. We will say, heat transfer from a surface to a moving fluid. That surface means a solid and a stationary fluid. To avoid too much memorizing, too much words ba? Okay, so it would be narrowed down into a simpler definition. Heat transfer from a surface, because a surface is always a solid to be considered, something like that, or a fluid, stationary, right? So from a surface to a moving fluid. Okay. Then if you want to be specific, just take it out to make it short. Heat transfer from a solid or stationary fluid, liquid or gas, to a moving fluid, liquid or a gas. Para way lubog. Okay? Di maka-episode ba? Kaya kung di mo siyang i-general, murag something missing man. Okay? Pero kung nakasabot ko sa iyong gimin, so muna to. So, heat transfer to convection. So, ang imong flux, dQ over dA. Okay? Then, H delta T, ganon, over delta L. Okay? Guys, thermal conductivity is also thermal diffusivity, or heat transfer coefficient. Okay? Diyan mo kailag na ma-original siya. Heat transfer coefficient, thermal diffusivity, okay, and thermal conductivity. Okay? Muna siya ang terms na ibaylo-baylo siya sa problem. Okay? Now, in convection, our thermal conductivity is just the same in a generic understanding, but this is now convective heat transfer coefficient. Again, convective heat transfer coefficient because this is under heat transfer through convection. So, it is represented in a small letter h. Okay. Don't be confused with the small letter h also under Max Planck constant. Okay, under the study of, you know, the quantum mechanics. The particle, you know, the particle duality, the wave-particle duality of elementary particles. Okay, for the photon. Okay, itong Max Planck constant times the frequency, right? Like that. But in here, the h here is not the Max Planck constant. H masado siya. The same. H represent 6.626 times 10 to the negative 34 joules times second, the unit of Max Planck constant. Here, our convective heat transfer coefficient is variable. it depends on the substance you are referring to because it has different convective heat transfer coefficient. Dili sa convection guys, specific yun siya nga convective heat transfer coefficient. Dili mo siya pwede tawag ng heat transfer coefficient kana may conduction. Okay? So you'll never use the terms anymore. Though this is also thermal diffusivity, but it is exclusively convective heat transfer coefficient. Because the thermal diffusivity, giangko na gid siya sa conduction daan. Okay? You get the point? So, just like, for example, let's say, we have Ninoy International Airport na aya. So, it will be changed to Manila International Airport. So, giangkon gid siya sa Manila. So, mao na siya natabo. Mo ang conduction, giangkon gid niya ang term na thermal diffusivity. Dili na maangkon sa convection. Muna, sa convection, specific na gito iha. Sama anang kuan, Mactan International Airport. Specific siya sa Mactan, Cebu na airport. You get the point? Like that. But this thermal diffusivity, maura na siyang Philippines. Pwede ka. Philippine International Airport. Okay? Could it be Naya or the Mactan International Airport? Okay. Belong mo siya sa Philippines. So that is the general. Just like this in heat transfer. The general is thermal diffusivity, equivalent to Philippines. Right? And conduction, equivalent to Manila. Like that. So giangko naman daan sa Manila ang kuan, ang thermal diffusivity. Sama sa Naya, giangko na siya nga, module siya ang airport sa Philippines. So dili na siya ang kunon sa Cebu. Okay, you get the point? So, ang Cebu mo siya convection. So, specific rin siya nga Mactan International Airport. So, mo sa ni siya convective heat transfer coefficient. Kaya ang general nga term, nga para gud ana sa general, giangkon man sa conduction daan. Okay? So, that's the analogy para masabtan natong dali. Okay? Pero actually, pwede lang gud siya mo na siya thermal diffusivity ang heat convective transfer coefficient. Pero di man ako maog refer good. Okay, in normal understanding. So when we speak of thermal diffusivity, it's always the thermal conductivity and the thermal diffusion coefficient. It's not the heat convective transfer coefficient. But in here, the H is heat convective transfer coefficient. Okay, the word convective will be put convective. Okay, so that's the identification. Just put convective. Ganan. Isumpot ang heat transfer. So, convective heat transfer coefficient. Meaning, adjective describing your heat transfer. Okay? An adjective describing your heat transfer. So, that is through convection. That's a convective. Ganan. You got the point? So, description siya ba? Before sa term. So, that's adjective in English, right? So, that's convective heat transfer. So, since that is coefficient, add coefficient. Okay, ganon. Diba? Para masabtan dito. Okay, now our DQ, our driving force, again, temperature. It's the same. Okay. And then, our unit is the same story. It's the flux, right? It is, heat is joules. Okay. Then, area is meter squared. Like that. Okay, so this is joules meter squared. Okay, like this. Second. Okay, this is the unit of your DQ. Okay, because of the area, joules meter squared second. Okay, ganon. And then your scientific law, this will be kinsa may nakaangkonan niya nga theory. It's Newton's law of cooling. Okay, and LC. So, it's very easy to detect the other word is FLC. Gokudra siya. Ang katapusan C. So, dili kayo memorized. So, FLC and LC. Ganon. So, FLC, so Fourier's law of conduction. And LC, Newton's law of cooling. Okay. So, acronyms only. By that, we can understand. Okay, NLC. So, Newton's law of cooling. Okay, Newton's law of cooling. And now, we have the formula for this. We get the rate. Ang rate yung pamisikat nga ganito, dili ang flux, ha? Okay, simplified man gud ang rate. Rate of heat transfer flow, ganon. So your rate of heat transfer flow will be equal to dq over dt, Okay. So here dq over dt. And then this gonna be HA ganon. And then this gonna be dq HA, okay, surface temperature na siya minus the temperature at infinity. Kaloka? Di ba nakakaloka? Okay? So, temperature at infinity. Why guys? Why infinity man siya? Or actually, this is the bulk fluid temperature. Why infinite? Because this is usually in the surrounding. Okay, the temperature in the surrounding is infinite. It never stops. It will never ends. Okay, in your room, the temperature will reduce if you off the AC, right? It's dependent on the AC you have, electric fan you have. But the surrounding is really, immeasurable. It will change anytime. It will goes up, it will goes down, like that. So you cannot predict. No certainty. So that's what we mean by temperature infinite. Okay, we cannot predict the exact temperature always. It will vary. Maybe after 4 hours it will change again. After the minutes it will change again. So there's no constant temperature in the surrounding and in the environment. Okay, so you get the point. That's why it becomes temperature infinite or the bulk fluid temperature. Ganon. Guys, our TS is the surface temperature, but other books represented this as a wall temperature. TW, but it's just the same. Don't be confused. Okay, for me, surface temperature is the more precise because wall is referring only to the wall. But sometimes, manggod, the fluid will go in the flat surface. So that's gonna be TS actually because TW is only for the wall and the floor is not a wall. Right? So for me, it's best TS rather than TW. But some books are putting TW. Okay, because it is exclusive only for the wall. So TW, right? Wall. WALL. It could be a concrete wall, a brick wall, a wooden wall, a plastic wall, something like that. Whatever. Okay? But if we mean a flat surface, di naman siya ma-apply. So that's why TS siya, temperature of the surface. Okay? You get the point? So my point only, don't be shocked that the subscript is changed to S. Okay? Because usually TW talaga siya sa mga old books. Okay? TW, not TS. Okay, guys? So, it's just the same. Okay? Temperature of the wall and the temperature of the surface. But usually, this is also the T1. The TI, usually. Okay? So, muna siya nahitabo. And then this T2, wala man siya dimension diri ang T2, no? Pero imo na siyang idua-dua dito sa mga changes in temperature kung daghan kag mga points. Ganun. Okay? Especially, i-combine mo ang convection ug ang conduction. Then makakuha naman kag tito-tito dito. Okay? It depends on the situation. Kung nakay point 1, for example, this is room 1, room 2, each have certain temperatures, right? So you can play around kung sa imong mga initial temperature dito, kung sa the final temperature dito. Makuha rin dyan nimo kay namin kay mga convectivity transfer ganon. Nasa kay area. Okay, kay square man yung room or triangle man yung room. So, na kay surface area. Length times width. O ganon. Plus the convectivity transfer. Yan, nasa kay dito yung thermal conductivity, which is normally given in the table, in the books. Thermal conductivity of the substances are given in the books, ha? If it is not mentioned, troubleshoot the operating conditions. What do you mean by operating conditions? Normally, it's gonna be temperature and pressure. Okay, for example, the fluid flow at 20 degrees Celsius and has a temperature, the interface temperature, wala siya gihatag ang kuan, thermal conductivity. So, unsa imong buhaton ana, go to the table and extract the value of thermal conductivity. It was just not mentioned, but the standard at that particular temperature, there's a thermal conductivity. This is also one way of, let the students and examiners think that when the problem becomes not the same in the sample problem, how did the students think for that particular problem? Kaya nalain na siya ang problem. Okay? So, muna siya purpose na you have to think. Kaya dili ka pwede magpaabot sa mga units, kaya pwede man ka na yung mga laing sources for that. In fact, you can also derive just to get that one. Then another option to get in the table, to get in the, graphs at certain operating condition. Mo gina siya technique pirmi. Okay, kung dili gini, wag gini na siya gihatag, it could either be in the tables, in the graphs, or you could derive that one through correlating other formulas. Okay? And then if you think dagan ka siya kuwang, then think another formulas. Because in algebra, if there are two unknowns, you must have at least two equations to use to solve for the unknowns. Like that. So it would be impossible if you have three unknowns and you have only two equations. Okay? Unless, again, if there is data to prove as per operating condition. Okay, for example, the enthalpy of heat formation of carbon dioxide, like that. So it's been given at 25 degrees Celsius. Then in the balanced chemical reaction, it was not given there. And then you try to compute for the heat. Right? So heat could either be NCP/dt at a specific heat capacity at a constant pressure, that's why it's Cp, or it could either be NCV/dt, it's at under constant volume, that's why Cv, okay? Or it could be MCP/dt in terms of mass at a constant pressure, that's why MCP/dt. So, tanaw mo ang mga quantities. Sabi ko magsalig premise sa MCP/dt lang. You get the point? It could also NCP/dt, NCV/dt, dependent on the thermodynamic processes. What is held constant? It could either be the pressure, it could be either by the temperature, it could be either the volume. You should look at it in that way. Okay? Ayun yung pagsalig sa katong kuan ra siya. Nga, mura dyan na premium yung saligan. Okay, kay magsa-usap ba yan na siya? Okay? Get the point? Then kayo mo, out of one equation, daghan kag ipasok diha para makakuha kag another formula through derivation. Okay? You get the point? Mana siya natabo. Okay. Now going back. So this is heat transfer through convection. This is also convective heat transfer coefficient. An hour agod. Okay, times surface area times delta T. Delta T is equals to temperature of the surface minus at infinite temperature minus infinite temperature. Now, this one, it depends on the problem, Okay, it depends on the problem if the infinite is big or small, because there's no question about that. Then if it's a negative value, then that is releasing of heat. Okay, releasing of heat is exothermic reaction. Okay, absorbing of heat, that is endothermic reaction. So if there is an exothermic reaction, so there will be also a negative enthalpy. So if there's a negative enthalpy, your chemical reaction is spontaneous or reversible chemical reaction. It will just proceed by its own without any adding external energy or without touching anything in your chemical reaction. So that's the point. So that's the basic chemistry. Okay? It will proceed by its own without adding any energies on it. So that's spontaneous. Okay? So the answer will be negative. Okay? Because it's released heat. So exothermic reaction. The reverse holds true, Absorbing meaning endothermic reaction. Okay, so if we speak about exothermic reaction, your enthalpy will be negative. Okay, take note. At the same time, your delta G, the gives free energy also is negative. So that is spontaneous reaction. Just think of that. If it is negative, then bingo, that is spontaneous. The chemical reaction will proceed by its own. It will be reversed. Okay, just like water will yield H2O2 and then it will reverse. H2O2 is equals to water. So the arrow will be going there and then it's reversible with chemical reactions. It's very easy for that, but if it is not reversible, irreversible, it looks like more difficult compared to the spontaneous. That's why we will be happy. Me, personally, I will be happy if I will obtain negative enthalpy. Okay? Nakakaloka. Okay? Ganun siya. And then you should be extra careful in your chemical reaction because that could identify where to add your heat. You add that in the reactant or you could add in the product. You get the point? So, your reactant, sorry kayo guys okay, this is spoon feeding, right? Reactant is equals to product, right? Reactant meaning system. Product means surrounding. Okay, so system and the surrounding. So system is the reactant. Now I said it releases heat to the surrounding. So when it releases heat to the surrounding, ang heat nipadong sa surrounding. Right? So you will say reactant is equals to product plus delta H in your product. So if it is endothermic, the reverse will do. You say reactant plus delta H is equals to the product, something like that. And it's delta heat of formation at standard 25 degrees Celsius, ganon. Because all substances have standard heat of enthalpy formation. That is studied in the physical chemistry. Okay? Physical chemistry, phychem. Okay, so you can relate that here also in the unit operations, because unit operations are more on physical processes rather than chemical. There's also chemical processes, but it's more on physical processes really. Okay, there's no change in, altered. By the way, the physical change means it is a conversion from the original form to another form, meaning there is an alteration of the form of the substance. For example, if this is a solid, and then it will become a liquid in the product. So that is chemical change. Now, if it is still a liquid in the product, even though you do a lot of techniques there, you separate, you extract, you crystallize. So that is physical process. So meaning, chemical reaction or chemical change depends on the state, okay, original state and original form of your matter. If it will be modified to another phase, okay, usually by, by interaction, by applying heat, right, burning, something like, or pyrolysis, or let us say thermal cracking, just like in petroleum industry, then bingo, that is a chemical change. Okay, but catalytic cracking is not a chemical change, because the catalyst, you will add on it to increase the rate of the reaction. It will never consumed somewhere in your reaction. So catalytic cracking is not a chemical process, separation process. It's still physical, adding of catalyst and inhibitor. Okay, like that. You get the point? Muna siya nahitabo. Okay, more dyan na yung timan-an. Usually po, if chemical change, the color will change. Okay, the color will change. You get the point? The color, the taste, okay, the smell. Okay, and it will produce another element or atom. Okay, for example, H2, it will become H2 plus O2, and then it will split to 2. So there's another element. So that's chemical change. You get the point? Oh, ganun siya. Okay, so that's gonna be the example of chemical change and physical change. Very important here, ha? Also. Okay, so this is physical change, ha? This is a heat transfer through convection. You got the point? So, muna siya nahitabo. So, Newton's law of cooling. And now we go to the heat transfer through radiation. Okay. Heat transfer. Muna siya yung pinakasikat. Heat transfer through radiation. Okay. Without heat transfer to radiation, all people will die. Okay. Because we are receiving the radiant heat of the sun in order for us to survive, the light of the sun. Okay? So without it, without photosynthesis, okay, that is useful in our plants to produce carbon dioxide and water, something like that, and a lot of carbohydrates in order for us to survive through the radiation of the heat coming from the sun. That's why photo. Okay? So photosynthesis light. So that light is coming from the heat transfer through radiation. So meaning to say, we don't have food. Okay, if the radiation will not be going to the plants, to the people, like this. If there's no food, then we will die. There's no plants, there's no trees, like that, everything. Because we survive in this world by eating food. And the oxygen also will be produced there. That's why it's become a photosynthesis. You got the point? Ganun siya. Wow. Okay, so the heat transfer to radiation, this is the most important heat transfer of all. So this is coming from the sun, light. Just like also me, I'm discussing you, and there's a light in the fluorescent releasing to me, and I have light. Without that also light, I cannot read if it's very dark. So there's a radiation of the light ray in going to my paper. I can see everything here. Okay, like that. So that is also heat transfer through radiation. And also in your laptop, in your devices, you cannot see the screen. You cannot see the resolution of your screen or the LCD, liquid crystal display of your laptop if there's no heat transfer through radiation. That is radiation, guys. Okay, it emitted light ray in your eyes. Okay, so without heat transfer radiation, our life will not be happy. Okay, because there's no really emission of rays, light rays. Oh my gosh, what will be the world will be if there's no light? I cannot breathe. Charot. Okay, you got the point? So our laptops will be useless, our mobile phone will be useless because if you own, there will be no light coming in your screen. Okay, so that is the purpose of heat transfer radiation. Now, what is the formula for that? The formula for that is, so let's start with the heat transfer flux. Heat transfer flux will be dq over dE again. Okay, and then it will be, sama siya formula ni Ining Higayuna. This one. Okay, guys, try to figure it out. Okay. After this, you can review other books, because the other books are better than me, more than better than me. Okay, something like that. Okay, or you can go over to your friends who are really, good academically in terms of mathematics and science, also better than me, like that. Okay, so you can refer to them also. Okay, more heads better than one. Okay, you get the point? Something like that. So we should not be conceited. Conceited meaning believing only for your own self. You can also refer other people in order for you to learn. Okay? That's very clear. Okay, but me in this discussion, I'll try to be comprehensive, and as much as I could, I try to spoon feed with basic theories and principles also. That's why I used with the basic problems, not the difficult one. Okay, so we have dq over dE is equal to, okay, the emissivity, andyan na naman tayo, emissivity times the Stefan Boltzmann law constant. Nakakaloka. Diba? Times the area. No need the area because it's still flux. As I told you, the area in the flux is still in the denominator. So this is times T4 pa siya. Okay. Mass flux. Mass. Naanad sa mass. Okay. Heat transfer to radiation flux is equal to dq over dA is equals to the emissivity times the Stefan Boltzmann law constant times the capital T raised to the power 4. Okay, now let's evaluate one by one. Capital T is a temperature in terms of Kelvin. Now, the Stefan Boltzmann law, we should memorize this constant. Okay, memorize this constant starting from now, students. Okay, 5.67 times 10 to the negative 8 watts per square meter, Kelvin 4, raised to the power 4. Okay, W over M raised to the power 2 times capital T raised to the power 4. Wow, raised to the power 4. Nakakaloka. Okay, so that's Stefan Boltzmann. And be careful. Stefan, there are two Boltzmann signs. We have the Ludwig Boltzmann and we have also the Stefan Boltzmann. It is very, very important to know the difference among the two. Okay, the Stefan Boltzmann law is exclusive for heat transfer through radiation under heat transfer under transport phenomena, and then Mr. Ludwig Boltzmann constant, key B, you remember that one? Key B, okay? If you can remember that one, that is exclusive for dealing with the universal gas constant and the entropy of the microstates. Entropy, the randomness and the disorderness of the system. Okay, like that. So that is entropy, delta S. So, our delta S, okay, that is Q over T, meaning to say that is joules over Kelvin. That is the unit for our entropy, delta S. Now, this delta S has a formula also, a specific gas constant times the capital T ln Q. Q is equals to the reaction quotient, a product divided by the reactant. Muna siya ang microstate, dealing with the molecules of the elementary particles that is covered by Mr. Ludwig Boltzmann. And then later on, he came up with a constant known as a Boltzmann constant, 1.38 times 10 to the negative 24. Like that. 24, like that. So this is joules per Kelvin. This is the only constant that has the same unit with entropy. Okay, because other constants, guys, don't have the same unit with the unit of the particular amount or, quantity. But this one is the same with entropy, joules per Kelvin. Okay? And this is a constant. Take note, this is a constant. But why the same unit with entropy? So meaning pala, entropy is this equals to this constant. So di ba? Parang, so unique siya. So just think of that. This is the only constant that has the same unit with a quantity known as entropy. Joules over Kelvin. That is Ludwig Boltzmann Constant, or key B. B stands for Boltzmann, equal to 1.38 times 10 to the negative 24. Then how can we obtain that one? Because we divide the universal gas constant to the Avogadro number. Andiyan na naman tayo. Kung saan itong Avogadro number sa Sotero? 6.023 times 10 to the 23 per mole. Kung saan itong specific gas constant. In here, we use the 8.314 joules per mole Kelvin. That's why we attain, through cancellation of units, we attain the joules per Kelvin for the constant of Ludwig Boltzmann constant. This is not the same with the Stefan Boltzmann law. And take note, the books will always say Boltzmann only in their discussion because they are on the present topic for the particular topic in the book. Okay, but there are also Boltzmann in the other topic. So for me, if I am the author of the book, I have to specify that it is Stefan Boltzmann Constant. But other books are always also using Boltzmann only. But there is also another Boltzmann, so it confuses also the students sometimes. Because there are two man siya talaga. So you have to specify na. So Stefan Boltzmann Constant and Ludwig Boltzmann Constant is not the same. Okay? So again, Ludwig Boltzmann Constant is, isubat ko na sa papel, 1.38 times 10 to the negative exponent negative 24 joules per Kelvin, and the Stefan Boltzmann Constant is equal to 5.67 times 10 raised to the power negative 8 watts per square meter times Kelvin raised to the power 4. And I thank you. Ganon. Muna siya difference sa Boltzmann constant. Be careful the applicability and the suitability of that constant. That's my main purpose of that discussion. Okay? Okay, any questions so far? Muto akong pinaka-point that we should not mix up. Okay? Because me also sometimes confuse that before. I research a lot for that also. Why like this? Why like this? Okay. Okay, muna siya. Now we go to the heat transfer through radiation na flow na gyud siya. So dili na siya flux. It will become dq is equals to emissivity times the Stefan Boltzmann law constant. So t to the 4 times the area na siya. Again, algebra, cross multiplication. Now, guys, what is emissivity? Okay. Emissivity is derived from the root word emission. Emission meaning release. Okay. What else? Release. Given off. Okay. What else? Expose. What else? Generated. Okay. Another term for release. A lot, right? Okay. What else? Wasted off. Something like that. What else? Another term for release. I think for only generated, given off, released, or produced. Right? It's just the same. Produced. Okay, so this is emission. Now, what is being emitted? So, of course, radiation. Because we are dealing with heat transfer through radiation. And what's in the radiation? It's always the ray. R-A-Y. And the ray is a ray of particle that we are referring to. Could either be an electron, proton, neutron, positron, boson, fermion, like this, quarks, lepton, like that, and a whole lot more. Okay, elementary particles, sub-element, under quantum mechanics. Okay, something like that. So you have to be extra careful for this also, that this is the ray particle that is being emitted through radiation. So now, emissivity is equal to the emission of the total actual radiated or radiant energy radiated by a substance over the actual total black body radiant energy emitted. Wala na ako gibukish kay maglibo mo ibukish. Ako ra nang pero akong ikuha ang kuan ang pinaka-importante. Ano siya? Actual sa substance nga radiation na emit over the black body radiation na emit. Parang gano'n, para masabtan din siya ba? Ratio. Okay, so that's why emissivity has no unit. Now take note, emissivity is not more than 1. It ranges from 0.1 to 1. Now, if you encounter problem this in the future examination, and then the emissivity is more than 1, then ayaw pugsa. That is not heat transfer through radiation by using Stefan Boltzmann law. Because it's stated there, 0.1 to 1 ra ang emissivity. Then use the other nuclear transmutation, radioactivity, katong alpha particle, beta particle, gamma ray, ganon. There's a lot. Okay, if you remember that in our nuclear chemistry. Actually, nuclear chemistry is a part of chemistry in the last part of the book. Ito ng mga beta particle, okay, beta ray. Beta ray can be stopped with a copper or metallic sheet. Ganon, di ba? And then the X-ray is also known as a gamma ray. Okay, and X-rays are discovered by Engr. Ganon. Radioactivity is discovered by Henry Becquerel. Okay? You get the point? Mga ganon-ganon siya. So you should also remember that one, ha? And then more on the disintegration of the substance, it will take after how many years? So there's a half-life of that particular substance. So mo na ito inyong gamiton dito. Kung ang visibility mo, labaw siya sa 1. Okay? Because this is not, because may ilan masabi mo, ikana siyang radiation is all about light, radiant heat of the sun, gano'n siya. But dito lahi mo to siya nga kuan. So, mo to siya usa nga radiation. So kaya siya radiation sa di siya. Okay, but kini siya nito lang ni siya kay sa ato maging life as a human being now. We cannot survive without the radiant heat of the sun. Okay? So if there's a radiant heat of the sun, then our body core temperature will be maintained. Okay, and then we can survive and we can live normally in this planet Earth. Something like that. Okay? So that is heat transfer through radiation. Muna na siya ang natabo karon. Okay, so DQDE, muna gyapon lang yung transfer guys. Joules lang gyapon siya. Okay? Joules, meter squared, second gano'n siya. Muna imong kuan. Heat transfer flux through radiation. Okay? So dili guys, Stefan Boltzmann law na siya. So SBL. So Stefan Boltzmann law. Ganon. Diba? SBL. So we have now 4 acronyms so far. NLV, FLC, NLC, and SBL. NLV, Newton's law of viscosity. FLC, Fourier's law of conduction. NLC, Newton's law of Choline. SBL is that Stefan Boltzmann law. And there's still one. Mass transfer. Grabe. Okay. Di ba? Masa na rasa, uy? Nakakalo kayo ng mass transfer. Taas ulit itong mass transfer. Time pasa. So, nahuman na ta guys. So, heat transfer through radiation. I think we can make this by 9 o'clock. Okay, mass transfer. Heat transfer, mass transfer. This is enjoyable also because it deals with more on the concentration gradient. Okay, then since I love chemical reactions so much also. Okay, like that. Okay, and I love to balance the chemical equation. Charot! Charot lang. So that I can obtain the stoichiometric relationship. Charot. Nakakaloka. Really? Yes. Mass transfer. Muna din siya sa atong kuan, atong transfer phenomenon, ang atong flux, ang atong weight, atong driving force, ang atong net. So yun na lang kayo siya kung mag-examination ta. Okay? So yun kayo siya guys. Imura na yung kuan. Okay? I have no microphone now. Then I have to talk without microphone. Charot! Kaloka. Okay guys. Okay. Anybody hear me? Charot. Hello? So, mag-mass transfer na ta. So mass transfer, unsa man ang atong transport phenomenon? Of course, mass transfer, right? Mass transfer. Okay. Mass transfer, our transport phenomenon. Okay, our flux will be, it could either be the mole flux and the mass flux, but since we are referring to the mass transfer, then literally we will use the mass flux. It's gonna be, wait, it's gonna be meter square, mass meaning kilogram, right? So, kilogram, okay, flux na may area, so it's gonna be meter squared times the time. Okay, this is second. So kilogram per meter squared second. Then this is the mass flux. Okay, our mass flux will be also dm, right? The flux man siya, mass man siya, small letter m. So dm, okay, over dA, okay, is equal to the mass diffusivity. Okay, mass diffusivity is the diffusion coefficient in which it's taken from area over time, meaning square meter over second, something like this. Okay, you get the point? Muna siya nahitabo. Okay, so muna atong flux. So let's say ano siya? Okay, mass diffusivity, right? And diffusion coefficient DAB. But here guys, very special, negative DAB. Ano nga may DAB sa Sotero? It assumes to be at least minimum of two components interacted with each other. But there's also only one component, no problem. But most of the times also have two components. Like DAB meaning two components, A and B. Ganon. A will flow to B or will diffuse to B. And then again, going back, B will diffuse to A. Ganon. Okay? So steady state. Ang steady state guys, mubalik maguna siya. Okay? Yun siya yung naman. Steady state gani, mubalik-balik siya. Going to A, going to B, going to A, going to B. So ano siya ba? Ano yun siya? Equilibrium. Okay? So muna siya steady state. Most of the time, we will deal with steady state diffusion. Not the non-steady state. Why? Because non-steady state diffusion is very difficult to analyze because again, same with the momentum transfer using a lot of equations and integral equations and differential equations. Okay? So it will just go to the steady state. Okay? Like that for further understanding. Because it's not also practicable to understand, the non-steady state. Okay? You got the point? Too much differential equations, calculus, okay? But if we study that intentionally, we can get that also. But we don't have time to scrutinize that calculus thing. Okay? Like that. So, only the basic atong mga kuan. Siya sayon ra ba? Di ta maabot atong mga, I think D1 to D25, differentiation D1 to D25, integration 1, integration 25. Siguro ang ma-memorize is only D1 to 5, the most basic lang yun siya for the purpose of derivation sa equation. Diha ra ko to katong mga ln, right? You get the point? Ln A over B, ganon, is equal to ln A minus B. Then ln A times B is equal to ln A plus ln B. Ganon. Ln E exponential to something, ln A is equal to 1. Ganon. Logarithm, ganon ba siya? Mga simple lang kayo siya. To the base 10 is equals to ganon. So, more to, dito na ko to ba itong learning, but sa the rest, di na siya pwede. Okay. Di na kaya. Because I'm not presently studying now, okay? I'm working. Okay, so I don't have time to, to go with that. Okay? But if we will intentionally do that, we can make it that also, of course. There's nothing impossible. Okay, so negative dA is B is equals to delta C over delta L. Delta C, guys, is the change in concentration. Okay? Mag-isip siya po ko transfer. Ganagin ko transfer. So, concentration. Okay? Change of concentration. Concentration gradient. Mga na siya na tabo. Okay. Now, ang sisunod, rate. Ang atong rate, mahimo na ni siyang dm dt. Okay, so, kaloka. Actually siya humanon og 9 o'clock guys ha. dm dt meaning mass. Derivative of the mass over derivative of the time or delta change of the mass over delta change of the time. Ganon. So, it's gonna be like that. dm over dt is equal to the mass diffusivity or the diffusion coefficient, negative dab. Okay, delta C, change in concentration, is gonna be C2 minus C1. And then if you have only one component, it's gonna be CA2 minus CA1. And if you have another component B, it's gonna be CB2 minus CB1. Like that, okay? It depends on the situation, how you play around the subscript or whatever. Okay, now, delta L is equal to, it's gonna be L alone if there's no changes in the direction of the horizontal axis of that movement of that concentration gradient. Or you can say thickness 2 minus thickness 1. But most of the times, it's not like that. It's only rare. You will use only simply the L. The delta L there is just the L or the length of your geometrical shape. For example, it is a window, it is a tank, the length of the equal to the diameter of the round opening, something like that. Okay, it looks like confusing a bit because we are used to say it as a diameter. Okay, but obviously the diameter is also the length of the opening. You get the point? So L is equals D. You get the point? That's why. And there's the height of the tank is h, right? And then you have the diameter and the upper portion and the lower portion, the bottom and the upper. And then that is round. The round have a diameter. So diameter is equal to twice the radius. The circumference is 2 pi r. Like that. And the area is the pi r squared or pi d squared over 4. So normally, we can treat the diameter as simply equals as L. You get the point? The length of the opening. You get the point? So that is. So it's gonna be L alone lang gid siya. So delta L. Or, shall we say, the thickness if the length is not given, otherwise not specified. Okay? Maruk man ang problem solving. If there is no length, then they would rely on the thickness to be used in the denominator. Okay? But if there is a thickness, and then there's a length, di mubalik ka sa original nga katong length. Okay? Like that. So you should weigh things na talaga siya. Bubasi ka sa original. But then if there's no given length, then use the thickness. Something like assure L. Okay? Ganon siya. Ano na nililin? Analysis na siya nga part. Okay? When your concentration will flow. Okay? Usually this is through a semi-permeable membrane. Okay? Membrane separation process. Okay? Like a filter medium, filter, F-I-L-T-E-R. When it passes through the filter, there's a concentration before going to the surface of the membrane. And then when it goes out, the concentration will change, of course. Okay, because it will be filtered. Of course, the concentration will never be the same. So it will become less concentration when it goes out to the membrane filter. So we can analyze also by a simple logic, that's going to be the case, of course. Okay, because it will be filtered out when it goes out of the membrane, so the concentration will become less. Okay, so that's going to be C2 minus C1, ganun siya. But the length of your membrane is just equal. It will never change. Because that is only the shape of the membrane of your filter. The diameter of your filter, like, for example, if you have a flask in the laboratory, and then the diameter of your flask will be automatically also the diameter of your filter because you put the filter there. Equal na gyud siya kay muporm man siya sa shape dito sa opening sa flask. So, your diameter of the flask will also be your length. Ganon. Since you have the concentration initially, before you pour the acid or the base on that flask, then you have the C2 and the C1. Okay? C1 will be initial concentration, and C2 final concentration. That measure that out. You can measure by the gravimetric method analysis. You can measure that in the, another titration like this. Or you can measure that through spectrophotometer by means of absorbance of light to determine the concentration in the laboratory. Spectrophotometry process or spectrophotometer. through light absorbance of different substances, then that digital device will automatically give in the LCD, meaning liquid crystal display of the screen, it will give the units of your molarity, molality, equivalent with per solid or the normality, ganun siya. Those are solubilities and expression of concentration of the substances. So spectrophotometry is more easy compared to other because this is faster. Okay, you just put the substance there and you will press there on and off, and you will operate the normal way. And there's a manual, then bingo, the concentration will be solved if you just put the chemicals there in the platform, like a circle, like that, okay? You get the point? So, baro din na siya, guys, ang imong L. Ay, mo kadlok na anang techniques. Okay, baro mo siya gi-refer anak niya, good? Okay, so, bitik-bitik na kayo na siya. Okay, so dN or dt is equals to dAB C2 minus C1 over L. So, delta L will be also over L. You get the point? Now, times area na siya. Kaya kung ano naman siya, rate flow. Okay, so it's gonna be minus DAB times the area, close and open parenthesis, C2 minus C1 over L. Now, guys, okay, I will teach you for something for this also. If you don't want a negative diffusion coefficient, what will you do? Just reverse the concentration. C1 minus C2. Get the point? Because other books also represented positive DAB. That's why it become positive DAB because we start C1 minus C2, not the C2 minus C1. Okay. Remember, the C2 is lesser concentration because it's the final concentration. Your C1 is always the higher concentration. When you perform also C2 minus C1, having this negative DAB, it will also produce, positive, something like that. Play around the units ba? Diba? C2 minus C1. Okay, C2, gamay man siya. So, let's say 2 moles per liter ang imong kuan, or molar. Your initial and final will be 4. So, 2 minus, ganun siya, diba negative? The negative times the negative in the other side, it will become positive, right? So that's why C2 minus C1 and as is the negative DAB. Now if you try to make that, para dili ka mo gamit og negative diffusion coefficient nga mo ay gidiscuss sa ubang libro, okay? O the other books discussing that no positive in the diffusion coefficient. Now change the concentration gradient as C1 minus C2. Why? Because ang imong C1 dako man siya 4. So 4 minus 2 positive siya. O something like that. So positive na siya tanan. Okay. Dideclare naman ni mudaan ang DAB nga positive. You get the point? My purpose of the discussion, why it arrived like that? Because the students will confuse on the equation because the author will not discuss that anymore on the book. You get the point? So that's the reason why, class, na the formula not the same unit in some cases. Okay, this is an example also. There's a lot also in the Nernst-Simon equation in electrochemistry. Okay, it will become positive, it will become negative, and then if it becomes positive, you will change, you will reverse that one, the reactant to the Phemonena technique, guys, na kay i-reverse if dili siya pareho gyud. Okay? That is only if you don't want to have a negative sign. Example, dm dt is equals to negative dAB times A times C2 minus C1 over delta L. Just leave it that one because the answer will be positive if you substitute values due to the fact that the concentration of the initial is always greater than the C2. Okay? Concentration 2. Now, if you don't want to put negative in your formula, just reverse C1 minus C2 is just the same. Okay? Questions? Any questions so far? Muna siya naitabo. Ako rin nag-investigate. Okay? Bisag imong butang mga figure, mo na siya may tabo. Mapositive good siya. Okay? So, like that. Now, okay. Unless, in the problem, gamay niya daan yung initial concentration. Hypothetical siya ba? Okay, it doesn't reflect to the reality, only for the purpose of solving the problem. Because there's a lot of problems like that also, hypothetical. Not to be in the reality. Okay, as long as it helps you to solve, to understand how to solve, just like that. That's hypothetical questions. Not reflected to reality, The only purpose is to help the students understand how to solve and how to analyze certain things. Okay? That's hypothetical. Okay? Ganun siya. Now, we go to the, ang sisundan niya guys, unit. Okay, discuss na ako ang unit. Kilogram per square meter per second. Okay, now, what is the scientific theory for this? This is Fick's Law of Diffusion. So this is F, L, D. Ganon. And now, you have now 6. Ilan po kabuo itong mga scientific theories? So we have now 1, 2, 3, 4, 5. Now, if I have a question, enumerate the 5 scientific theories in transport phenomena. 1 to 5. Let's say I give an examination. You will say Newton's law of viscosity, Newton's law of Choline, Fourier's law of conduction, Stefan Boltzmann law, and the Fick's law of diffusion. Now, perfect. You have 5 points already with that question. Enumeration and list of scientific theories involved in transport phenomena. Okay, like that. And then question number 2. Blank is a rate of transfer that based on concentration gradient. Ganon. What choices? Your answer will be mass transfer. Okay. Number 3, a rate of transfer that based on temperature gradient. Your answer will be heat transfer. Question number 4, it is a transfer or rate of transfer based on the velocity difference. So that is momentum transfer. Naranasan ko mga brain cells. Okay. Ganon. What is the formula of dynamic viscosity? Ganon. Fill in the blanks, yapon siya. So that is kinematic viscosity times density. Ganon. So what is the value of kinematic viscosity? So, length squared over time. Ganon. So what is the formula of Reynolds number? That is density times velocity times the length over the mu, dynamic viscosity. Ganon. So what is the formula of momentum transfer in terms of flux? Ganon. So d tau over d area is equal to the dynamic viscosity times d velocity or the change in velocity over dx, the horizontal direction of your liquids to flow or fluids to flow, something like that. So that is your momentum flux. And then another question. What is the general formula of a flux? Flux is equals to rate of transfer over the area. So the rate of transfer means any kind of transport phenomenon could either be mass transfer, heat transfer, or momentum transfer. Ganon. Muna siya yung mga question na it helps you to think. Hindi siya multiple choice. Okay, like that. And then question number 2, derive a new equation obtained from mass transfer in correlation to ideal gas law. This is a question. Okay, like that. So you will derive an equation by linking the ideal gas law and the mass transfer original formula. So ako na lang siyang i-memorize. Okay, nakasabot naman ko. So that is dNA. Charot. Na is equals to the mass diffusivity times the area over the specific gas constant R times L times the temperature over the density, not density but the pressure 2 minus pressure 1, okay, over the length. This is quite difficult, guys, because it involves a lot of quantities. This is the time that there's a chance you rambled what you memorized. Obviously, right? I become mixed up a little bit. So this is the time. And you have to think also like that. Okay, just like 40 times 4 is equals to 160, not 1,600. After saying that in public, you can really filter that out after 10 seconds, 1 minute. You can correct that immediately if your brain cells are working properly. Something like that. But if you'll never think what you are talking, then you will never correct that after your speech. 1 hour, 2 hours. Me, I corrected it immediately because my brain cells really corrected that somewhere along the way. That's gonna be like, especially if you are in the public. This is just virtual like discussion. Nobody cares to watch this, I know, because this is very lengthy and this is science, and they're not interested also with science, something like that. Okay, so like that. Now we change immediately if we correct something, if we corrected something like that. Okay. Now, can we do that in terms of density? Yes, of course we can do that also, because we can correlate density and concentration and the pressure. Get the point? Density is directly proportional to the concentration, directly proportional to the pressure. So obviously, we can say also that, okay, that the mass transfer, or the NA, okay, is equal to the negative dAB, diffusion coefficient times the area times the density 2 minus density 1 over L times the RT times L. Now, if you memorize in that way, then prove it by writing. Prove it by writing, and then if the units will agree, then that is, you have a correct formula. If it is wrong, then change your formula. Your memory only fails. Okay, something like that. So you can prove by units. Okay, sometimes your memory fails really. Okay, that's the point there. Okay, so especially too much quantities involved in here in correlation of ideal gas and concentration gradient and mass transfer. Okay, now we will show you the density, because I have a little bit of confusion with density, guys. I'm having no question with the pressure, I understand already, and the concentration, but I don't really exactly understand this at this on the spot. Okay, I have a little confusion with density, and I need to prove now. Okay, naglibog jud ko kay na ha, kilogram per cubic meter, and then concentration is very far from kilogram per cubic meter, and why makancel siya somewhere along the way. So I need to troubleshoot that one now on the spot. Naglibog ko kay na problem ana guys nga akong gi-solve. Naglibog jud ko pag-ayo. Sus, wa jud ko kakuha. Giditso ra siya subtract ang density. So ano kan giditso subtract ang density no? Ako jud siyang gituki. Akong gibuhat ang mga ideal gas law, mga relationships sa density. Mao day ang density directly proportional siya sa concentration. Directly proportional sa pressure. So i-ratio nimo mga wala tong ubang quantities, but pag substitute na ko dito sa solve ko balik sa laing problem related gyapon sa density, di lagi makuha mo to. Ako na sa gikuan. Kan ako na dyan na siyang i-prove nga no. Nakakaloka. Lagi naglibog dyan ko sa density, guys. Because that is not common na ang density sa mass transfer. Pero medyo ihatag diha ang pressure and concentration, but it's seldom only to use the density in the equation of your mass transfer flux and the rate of mass transfer. Okay, don't be confused with the rate of the mass transfer. The rate of the mass transfer is just only the mass flow rate. Okay, and your mole flux or your mole rate flow is always your molar flow rate. Bitik-bitik na sa terms, guys. Okay, like that. What is the molar flow rate? Maura yun na siyang ipot-pasabot sa what is the molar mass transfer. Molar transfer, not mass transfer. Molar transfer. Ganan. Okay. Ang molar o ang mass, lahi man siya. Okay. Di ba? Correct din ako immediately. That means my brain is working. You get the point? If you never correct it, meaning lutang. Okay. You get the point? So, especially if talking about numbers, we need to correct that one. Okay. You know, guys, what's the time now kay matug na ko, katugo na jud kay ko. Charot! Matug na ko char. 8:56. Okay. Muna na siya karon. Okay, guys. I will correlate the density to the mass transfer, ha? Okay. So, density, mass over volume. Ganon. Okay? Density rho is equal to mass over volume. Okay. I have no question with the pressure and the concentration. Kaya nakasabot na jud ko siya. Okay. Pero kani siyang density, naglibog pa ko gamay. Okay. Because of the units cancellation somewhere along the way. Okay. Now, the concentration, guys, is moles per liter. So, this is gonna be the N, small letter N, over the capital V. So this is formula of the concentration or the solubility or the molar N over V. Okay, ganon. Now, we have the ideal gas law. PV is equals to nRT. At 1 molar, basis of calculation, 1 molar solution of a gas, and at a standard temperature or pressure, temperature of 0 degrees Celsius, 273.15 Kelvin, and 0 atmosphere, and then Badin, occupy 22.414 liters of a gas volume according to Mr. Dalton's law. Okay, so we will remember that one. Okay, so now PV is equals to nRT. Okay, ganon. Now guys, okay, in this PV and RT, troubleshoot the quantity that relates to density and the concentration. It's gonna be the density mass over volume because there's PV here somewhere in the PV. So solve for the value of V. So this is gonna be V is equals to density times the mass. Tama ba? No, it's not. V is equals to mass over density in algebra, cross multiplication. So, substitute that one. Ang purpose na to ni ining higayuna is not to alter the density because this is what we want to find out, that it's gonna be density gradient in the topic of mass transfer. Density 2 minus density 1. So I told you every time, posible siya tanan yun siya dahil mga mole gradient, mass gradient, pressure gradient, pressure fraction, volume fraction, temperature gradient, a lot, concentration gradients. Pwede magod siyang density gradient po. Okay, D2 minus D1. So not limited only to pressure or to volume 2. We should maximize all the quantities that can be substituted there, assuming that we will use the logic principle of ideal gas law. Okay, gas man atong gipasod ining higayuna sa atong membrane separation. Ganan, di ba? Or an ideal solution. Okay? Which has an activity coefficient equal to 1. Okay, but an ideal solution have an activity coefficient equal to 1. An ideal gas has an activity, not activity coefficient, but compressibility factor Z equal to 1. Okay, so the same purpose, but the terminology is not the same. Kung sa ganito, from liquid solution, ideally, so activity coefficient A is equals to 1. But for ideal gas, represented as Z. Z, compressibility factor, is equals to 1 to determine whether it is an ideal gas or a real gas or non-ideal gas. So, ako rin gi-relate siya nga mamaura siya principle. Okay? So, don't forget also the activity coefficient, ha? Because if the activity coefficient A is more than 1, then it is not an ideal solution. It is not an ideal mixture. Okay, something like that ba? Okay, so PV is equals to nRT. So, P is equals to M, ganon, over density. Okay, guys. Then, ang N na to, ato na siyang i-breakdown here. So, concentration is equals to N over V. So, our N will be equal to, it's gonna be C times V. Concentration times volume. Okay. So, concentration times volume over RT. Now, guys, take note. The volume also is equals to mass over density. The substitute also in the volume here. So, it will become now as pressure over mass over density is equals to C mass over density times RT. Then, na-common siya. Nga mass over density cancels the mass over density. So, we have now pressure is equals to CRT. Meaning, pressure is equals to the concentration times the universal gas constant R times the capital T in Kelvin. So, this is our first equation with regards to pressure. Okay? P is equals to CRT. Okay? Now, this is very useful because if we have two pressures inside pressure and outside pressure, you can treat that as a P1. Okay, P2 and use ratio and proportion or equilibrium process steady state. So we can say that P1 over P2 ratio and proportion. So P1 over P2 is equal to C1, okay, C1 R1 T1 over C2 R2 T2. Now take note, guys. Does the universal gas constant change somewhere along the way? You're treating that as a negligible and constant, right? So automatically, what will happen? Will be happening here. This gas constant and T will be cancels out because you are using the same substance. Okay, like that. Liquid, gas, ganun siya. So it will be cancelled, then it will become now automatically as P1 over P2 is equal to C1 over C2. That's why, guys, we can put directly pressure instead of concentration because of this correlation. Right? The original formula of mass transfer is equal to the negative dAB times the area times the concentration 2 minus concentration 1 over the L. That's why we substitute also the in terms of P1 and P2. So P2 minus P1 just because of this purpose. Okay. But since we are using that equation already, we will include now the R and T. R and T there. The gas constant and the T. In here, we just remove the R and T because for the purpose only of the correlation. Okay? This is not yet the actual formula of the mass transfer. But when we substitute that there, carry the R and T as 1 only. R, not 1, not 2. And T2 as T only. Okay, pareho naman yun siya. Sa component 1, sa component 2 mo, na siya nga. Yun na. So, now gusto man ako ang density. So, ako na ako inihigayon na. Okay, so, we come back with this density equation, right? So, pressure, nakakaloka. Mass over density is equals to CVRT. Okay, now, di ba guys na kay volume? Kuhaonin mo ang volume in terms of, kung makancel man mo ang density, so ay sa hilab T. Okay, so, your purpose man is to arrive with density, so don't touch it. Because if you try to put value in your volume, then the mass over density will be cancelled. You will defeat your purpose. Okay, like that. So just leave it in that way. So this is gonna be solve for density. So density C V R T. Okay, like that. Pressure times mass. O, nakakaluka. Ang haba. So density, concentration times volume times universal gas constant times T is equal to pressure. Okay, ako kani ha. Ato yung tukion. Okay, now density. So density will be equal now to pressure times the mass over the concentration times the volume times the RT. Okay, get the point? Ganun siya. Okay, guys? Ganun ka siya. So density P times mass times C times V times RT. O, diba? Ganon. Okay. Muna na siya netabo. And then review. It will be feasible enough or not. Meaning feasible if EA